In this video, we want to look at the concept of differentials. So let's suppose we have y, which is some function of the variable x. We can then look at dy, which is known as the differential of y, which represents the change in y. And here's what it's equal to. It's equal to the derivative of y with respect to x times the differential of x. So again, dy represents the differential of y, and dx represents what we call the differential of x. And let's see why this expression makes sense. Suppose dy dx is 4, and that would tell us that y goes up by 4 units for every 1 unit increase in x. But suppose the actual change in x is 2 units. What will be the change in y because of this? Well, if y goes up by 4 units for a 1 unit increase in x, but if x increases by 2 units, we just multiply those two terms together and we get 8. So basically y ends up going up by 8 units because of x increasing by 2 units. Now let's look at another example. Suppose y is a function of 2 variables, x and z. Now how do we find the differential of y? Well, dy, the differential of y, here's what it's equal to. It's equal to the partial of y with respect to x times the differential of x plus the partial of y with respect to z times dz, the differential of z. And let's see why that makes sense. Suppose the partial of y with respect to x is, again, let us say 4. So y goes up by 4 units for a 1 unit increase in x. And let us again suppose that the change in x is a plus 2 units. So in this case, this first expression here, this first term is 8, and that represents the change in y from x going up, holding z fixed, holding dz as equal to 0. Now, let's add to that the change in y from z changing. Suppose that the partial of y with respect to z is 3. So that says that y goes up by 3 units when z goes up by 1 unit. But how many times did z go up by? Suppose z went up by 4 units. So in this case, if y goes up by 3 units for a 1 unit increase in z, but if z goes up by 4 units, we multiply those two numbers together, which is 12, and that gives us the change in y from z alone going up, holding x fixed, or when dx is equal to 0. So now the total change in y, called the total differential of y now, is equal to the change in y from all possible sources of change, from x changing and from z changing. We have to add the two together, and that tells us the total change in y was equal to 20 from both x and z changing. Okay, let's give another example where we have a specific functional form we can work with. So let's suppose again that y is a function of x and z, and it's equal to 3x squared times z. How would you find the total differential of y? dy, the total differential of y from all possible sources of change, is, again, let's just write that out, partial y partial x times dx plus partial y, it's always plus because you're summing up the effects on y from x and z changing, plus partial y partial z dz. And what is that equal to? Well, the partial of y with respect to x is going to be 6x times z times dx, which is this term right here, plus the partial of y with respect to z, which is just 3x squared times dz, and there is your answer. Let's try one more example, and this is from economics. Suppose that the saving function is as follows. Saving is a function of income and the interest rate for a given individual or a given household, let us say. So what would be the total differential of the saving function? ds would equal partial s partial I di plus the partial of s with respect to I times di. So let's put in some numbers here so it makes more sense. Let's suppose that the change in saving when this household's income goes up by 1 unit or $1 is 0.1. So that would say that saving goes up by 1/10 of a dollar, or by 10 cents, for every dollar increase in income. And in economics, we call that the the consumer's or the household's marginal propensity to save. But the question is how much did saving go up by for this household? Well, let's suppose saving went up by $100. So if I multiply the marginal propensity to save times the change in income, we get, let's see, what is that? $100 times 0.1, which gives us $10. Saving goes up by $10 for this household because their income went up by $100 and they saved 10 cents of every additional dollar of income earned. Plus, what else affects saving? Let's suppose the change in saving as the interest rate goes up by 1 unit or 1% is, I'm just going to make up a number here, let's say $200. But the question is how much did the interest rate change by? Suppose the interest rate increased by 3 points or 3%. And so now saving is going to go up by what, $600? Because of the interest rate increasing by 3 units or 3%, and saving going up by $200 for every 1 unit or 1% increase in the interest rate. So in this case, for this household, the total change in saving is $610 due to income and the interest rate changing.